Okay, so we just derived the four sum and difference identities involving sine and cosine. We're ready to do some problems. But before we do problems, let's just write down everything that we have. Now, you don't need to memorize these, but you have to know how to use them. So we have sine of alpha plus beta is sine of alpha cosine beta plus cosine alpha sine of beta. That one we kind of pseudo-derived because we derived it in a special case using that geometric diagram. But the remaining identities we derive fully from this first one. Sine of alpha minus beta is sine of alpha cosine beta minus cosine alpha sine of beta. It just has minus signs where the plus signs are in the first identity. Then we had the cosine of the sum, cosine of alpha plus beta, is cosine alpha cosine beta. Funny thing here is, even though there's a plus on the left-hand side, on the right-hand side we have a minus now, sine alpha sine beta. And cosine of the difference, alpha minus beta, is cosine alpha cosine beta plus sine alpha sine beta. So the cosine formulas have cosine, cosine, sine, sine kind of pattern to them. But the sine formulas have the sine and cosines mixed up in each term, right? One sine with another cosine, one cosine with another sine. So now let's do some problems. So what you might see on an exam is, we'll call this exercises. Number 1, find the exact value of the sine of 105 degrees on no calculator. Of course, with a calculator, you could just plug in 105 degrees and tell you the sine. And so I'm trying to think of the angles whose sines and cosines we know by heart. We know 30 degrees, 45 degrees, 60 degrees. We're going to use those now and apply these identities to calculate trig function values for other angles. What you got to do here is you got to observe, and once you see a few of these, you get the hang of it. Observe that we can think of 105 degrees as, one way to think of 105 degrees is as 45 plus 60 degrees. That adds up. 45 plus 60 degrees is 105 degrees. I can add up two of those familiar angles, I know, 45 and 60, to get 105. That means sine of 105 degrees is the sine of 45 degrees plus 60 degrees. And now what I can do is I can apply the sine of the sum identity. I have that form, sine of alpha plus beta. So now I refer up to the identity, and I'm just going to plug into the right-hand side. It's sine, I don't write alpha, it's sine of 45 degrees. I don't write beta, I write cosine of 60 degrees. Plus cosine of alpha, cosine of 45 degrees, sine of 60 degrees. And I now have four separate trig function values that I have memorized. Sine of 45 degrees we know is square root of 2 over 2. Cosine of 60 degrees, cosine of 60 degrees is 1/2. Plus cosine of 45, also square root of 2 over 2. And sine of 60 degrees is square root of 3 over 2. So I'm just using those familiar values we have. Now I multiply fractions, so I get square root of 2 over 2 times 2 is 4, plus square root of 6, multiply the radicals over 4. And then I can write this as square root of 2 plus square root of 6 all over the common denominator of 4. There isn't much more you can do with this. You cannot add square roots, unlike square roots. Adding unlike square roots is like trying to add unlike terms. You can multiply unlike square roots, but you cannot add them. Okay, and there's our answer to number 1. There's the exact value of sine of 105 degrees. If we used a calculator to get a decimal, we should get the same decimal value by evaluating this square root expression. Okay, so let's try another one. Let's find the exact value of sine of pi over 12. That's pi over 12. Now, this is in radians now, so it's a little trickier now to figure things out. If you want to go to degrees, pi over 12 radians is equal to 15 degrees. You could figure out the problem with degrees and then go back to radian measure, or you could just figure out with radians directly, working with the fractions, because we've seen how we get pi over 12s in some of our previous graphing situations. But here, if I notice that pi over 12 is 15 degrees, if I make that observation, I could take 45 degrees minus 30 degrees to give 15 degrees, right? So what I can do is I can just observe that 45 degrees, that's pi over 4 minus 30 degrees is pi over 6. That's equal to pi over 12. And you don't have to jump right to this form. You can think in terms of common denominators, because pi over 4 is like 3 pi over 12. Pi over 6 is 2 pi over 12. 3 pi over 12 minus 2 pi over 12 is pi over 12. So it checks out. So the challenge here is to describe the angle we want, pi over 12, using these more familiar angles, which it's nothing wrong if it helps you to think in terms of degrees, to get rolling on it, to switch to degrees and then go back to radians. So sine of pi over 12 is the same as sine of, now I'm going to use a difference, right? I'm going to subtract pi over 4 minus pi over 6. And so the identity that I would use here is the sign of the difference, alpha minus beta identity, which is up at the top of our sheet. And you'll always have that handy, so you can just refer to it. Instead of alpha and beta, I'm using pi over 4 and pi over 6. So I get sine pi over 4 cosine pi over 6. The sign identities, if there's a plus sign here, there's a plus sign there. If there's a minus sign here, there's a minus sign here, right? And so I have cosine pi over 4 sine of pi over 6. And we got to write down what these values are. Now you're going to see a lot of these same fractions over and over again, because there really were only a few trig function values that we had memorized. We're going to see a lot of these square root of 2 over 2's. Cosine of pi over 6, that's cosine of 30 degrees now, that's square root of 3 over 2, minus, I got another square root of 2 over 2 times sine of pi over 6 is a half. So it looks like I have square root of 6 over 4 minus square root of 2 over 4. which is going to be square root of 6 minus square root of 2 all over 4. And I can't combine those radicals, can't add them together. So that's my answer for number 2. So we did a sign of the difference. I guess we also did a sign of the sum, one with degrees and one with radians. Let's do another problem. Number 3, find the exact value of cosine of 17 pi over 12. 17 pi over 12. Okay, now there's going to be a little bit of twist to this one, because if we're getting to a very large angle or a negative angle, we might want to imagine drawing that angle in standard position. First of all, let's see, 17 pi over 12. Now I'm going way back to the beginning portion of this course, right? I know 12 pi over 12 is the same as pi, so 6 pi over 12, 12 pi over 12, 18 pi over 12 would be 3/4 of a circle, and we're not going to do 18, we're going to do slightly less than that. There's a drawing of 17 pi over 12. And because we know that this much, one way to think of it is 12 pi over 12, we know our reference angle has to be 17 minus 12, or 5 pi over 12 is the reference angle. We also know our terminal side is in quadrant 3. So what I'm going to do is part of our old-fashioned analysis before we go ahead and apply one of these identities. What I can say is cosine of 17 pi over 12 is related to cosine of the reference angle, right? Cosine of 5 pi over 12. And cosine of 5, let's see, is it positive or negative cosine of 5 pi over 12? Cosine of the reference angle is positive, but the angle we want, 17 pi over 12, which is the blue, by the way, that comes down here, is in quadrant 3, so its cosine's negative. We need to take negative the cosine of 5 pi over 12. And cosine of 5 pi over 12. Now this one I can almost figure out just from radian measure. 5 pi over 12, I can think of it as 2 pi over 12 plus 3 pi over 12. 2 pi over 12 is pi over 6, plus 3 pi over 12 is pi over 4, pi over 6 plus pi over 4. And again, if this radian analysis is just driving you crazy, go ahead and convert to degrees. There's nothing wrong with working this problem out in degrees. I just want to give myself some more room here. So cosine of 17 pi over 12 is equal to minus cosine of 5 pi over 12, which is minus the cosine of pi over 6 plus pi over 4. And so we're going to apply cosine of the sum identity with a little added hitch that we got to remember. We got a minus sign out in front of everything. So everything that follows is going to have that minus sign applied to it. So the cosine of the sum identity is cosine of the first, cosine of the second. I can be referring to my identity sheet here, cosine of the sum, third one down, minus sine of the first, pi over 6, sine of the second, pi over 4. So I have minus, in square brackets, cosine of pi over 6 is square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2 minus a half times square root of 2 over 2. So I have minus square root of 6 over 4 minus square root of 2 over 4, which is actually, when I distribute the minus sign, minus square root of 6 over 4 plus square root of 2 over 4. It's really just the opposite, I think, of our previous answer, right? And you can think about why that might be true, but here we got this one. So I wanted you to see one where we did a combination of working with reference angles to getting a smaller angle, and then put this up a bit. There we go. I think we got it all in one. And then applying one of these sum or difference identities. So that's the end of this portion. We have more problems in the next video.